Hi everyone, we are going over learning targets 8 and 9. We made it, it's the end of the chapter. So we are going to be using this stuff in real life now. In mass, well, think about a suitcase. When it is empty, it's not that heavy. But depending on what I put in it, if I put some clothes in it or if I put a bunch of textbooks in it, the density could change. So although the volume remains the same, the capacity of what I can put into it, depending on the items, the density, the mass of it will change. So that's important to realize. So let's go over some examples. Norris threw a plastic toy in the tub for her dog, but there's a problem. Puppy doesn't like putting his face in the water. If the weight of the toy is more than 350 grams, it's going to sink. So we want the density and the density and the volume of the toy is 453 thousandths grams per milliliter, and the volume is 673 and 45 hundredths milliliters. Is it going to sink or float? So we want to kind of remember that mass is equal to density times volume. So they're giving us both the density and the volume, so I'm just going to multiply them. Now, you don't need to show this. I'm just showing you that when you multiply density and volume, these units cancel out, but they have to be the same. So if it says grams per milliliters and then the volume is in cubic inches, that's an issue, and then we have to convert things. But whenever you multiply density times volume, assuming that your density is per whatever your volume is, those will cancel out automatically, and then you just have your answer. So what's going to happen? It's going to float, because 305 whatever grams is less than the 673 it's going to take to sink. So it's going to float. All right, next example. Mary purchased a new drawing box. The height, width, and length of the box are 12, 6, and 3 centimeters. She wants to fill the box with pencils. The density of a pencil is 300th pencils per centimeters cubed. How many total pencils can she fit in the box? So I figure out the capacity, the volume of my box, which is 216 centimeters cubed. From there, I need to remember that the density is 300th pencils per centimeters cubed. Notice that my centimeters cubed matches my centimeters cubed, so I know that those will cancel. And I get 6 and 48 hundredths pencils. Now, we're not breaking pencils here. So that's 6 pencils. I can't fit a 7th pencil in, so 6 pencils total will fit into the drawing box. Number 3. The density of the American white oak tree is 752 kilograms per cubic meter. If it has a circumference of 450 centimeters and the height is 8 meters, what is the approximate number of kilograms? So let's focus on, we got a lot going on. First of all, we need to realize that a tree trunk is probably a cylindrical type shape, okay? Now, it might not be exactly, of course, but we are approximating here. We're using shapes to figure out what it might be. So we have 8 meters for our height, and we have where did I go there? I'm sorry. We have 8 meters for our height, and they also told us that the circumference is 450 centimeters. So I don't know what the radius of the diameter is, but I'm going to use the information to work backwards to find the diameter. So I substitute 450 in for circumference. I divide by pi, and I get roughly 143 and 24 hundredths. Now, I'm not going to use a rough amount. I'm going to divide that by 2 and use this big long decimal so I can be as precise as possible. However, notice I am in centimeters, and that's an issue because my height is in meters. I need things to be the same. So I am going to, because it says per cubic meter up here, I'm going to switch my centimeters to meters. Now, you are supposed to know how this happens. Centimeters to meters is I don't want to say common sense like it's an insult, but it's a very common conversion that you should be aware of. There are 100 centimeters in a meter, so all you do is divide by 100. Basically, this decimal moves over 2 places to the left because I divided by 100, and I now have approximately 72 hundredths of a meter. So when I substitute this into my formula for volume, my height goes in for height, my radius goes in for my radius, and I get this decimal, Now I am using my calculator to carry this through, so I'm not rounding early. And then my volume is going to be multiplied by the density so that I can figure out what the mass is. So now that I have meters cubed, I know that those are going to cancel out, and I have approximately 9,694 kilograms. It didn't say where to round, so I would write as many decimals as I wanted to. A candle maker is having a silicone mold made for her new cone-shaped candle. The mold will be created by removing a cone from a cylinder. So I'm thinking when I hear that word remove, subtraction. The diameter of the cylinder is 12 centimeters and its height is 14 centimeters. I'm happy about that because I see centimeters and centimeters. Silicone's density is 2.3296 grams per centimeters cubed, and it costs $50 per pound. So centimeters cubed matches my centimeters, but I'm seeing that pound and I'm not really sure what to do. What would the price of the mold be? So I definitely know that I need to find the volume of what I'm filling here. So I'm going to remove a cone from the cylinder. So I'm going to find the volume of the cylinder. I'm going to find the volume of the cone, and these are very, right, I label my diagram. These are not hard values to find once I do that. And these are my two values. I subtract, and I get 336 pi centimeters cubed. Now, when we're doing real life problems, we definitely have to approximate pi because, as we continue here, we're going to use the pi button because I can't tell you like, oh, I would like 2 pi centimeters, please. That's not something we know. So I multiply it by the density. My centimeters cubes cancel, and now I'm at approximately 2,459 grams. So what I need to do with that, though, is figure out per pound because it costs $50 per pound. These are expensive things, people. So how do I change grams to pounds? Well, I'm going to look at the conversion chart that you will all be given, and I see that 1 kilogram is equal to 2.2 pounds. Well, kilogram is close to a gram. So to change my grams to kilograms, because I need that to happen, I simply, again, you should know that there are 1,000 grams in a kilogram, so I need to divide by 1,000. So I moved my decimal place to the left 3 spaces. And again, the kilograms to grams thing, that's one that you're expected to know as a human being. I don't mean that rudely, just it's an expected one. And then we have our kilograms. Now we can multiply that, because we want to get it to we want to get it to pounds. So I'm putting pounds over kilograms, so my kilograms cancel. And I have approximately 5 2/10 pounds. When I multiply that $50, whoa, that's a very expensive mold. It's $270.50 just for the mold. I know where to round for money because I should always round to the nearest cent because it is money. That is it, ladies and gentlemen. I will see you in class. Have a wonderful day.